Hello and welcome all to the winter session of Sea Conversations. I am Dushyant Dasher. I teach at the School of Environment and Architecture. Sea Conversations are a school's engagement with the world that brings in discursive rigor, as well as joys of connecting to new imaginations, voices, and ideas. This is the 18th cycle of Sea City Conversations, and this series is partly supported by Urban Center Mumbai. The winter series of Sea Conversations titled States of Matter has 6 talks from around the world. And this series of talks are curated from the research interest of me and my colleague Milind in questions of materials, matter, the making of built forms, and new phenomenologies of inhabitation. This series intends to open discussions and interrogations on the dialectical relationships between form and matter, technology and phenomena, between the forest and factory, the kitchen and laboratory. So today in the third conversation titled Growing a Building, we have Manjunath with us. This talk inquires into the methods of perceiving the reality of hidden forces like gravity, heaviness of earth, direction of wind, variation of pressure, and their translation into form and space. So welcome Manjunath. Welcome to C. I will introduce Manjunath. Manjunath is an associate professor at the Wadiyar Center of Architecture. His journey started with his master's in civil engineering from the University of Visvesvaraya College of Engineering in Bengaluru in 1985. In the same year, Manjunath began working with Umesh B. Rao and co. as a leading structural engineering consultancy in Bengaluru until 1994. Since its inception, Manjunath and co. has been working on designing and detailing with specialized techniques for material handling plants. Their team has designed thermal stations, townships, hotels, industrial buildings, housing, apartments, and I mean these set of projects don't define what he does. I think there's much more. So we will look through it today. Welcome, and today we'll start the conversation and flow into the works at different stages and relevance as we move along. And I would also request my colleagues at C to join in whenever you feel to connect to the conversation. So yeah, we'll over to you, Manjunath. Let's start. Let's begin.
Lovely, Dushyant. Yeah, it's lovely to catch you up, and I'll basically, it's uh, I talk about more of questions, rather than So let me just present you the first slide.
Mhm.
Uh, the reason why my interest to grow a building uh, came up only in a way that what we what we usually do is basically, as engineers, we follow set of rigid boundary, a boundary which doesn't have any soul or reference. It is fixed by somebody who even not there, is not in existence. So what is called as codes, or basically some regimental way to look at the whole system. uh, so and we started looking at education, and then started building the building in the direction of the education. Okay, so we were more or less put in a way that you excavate without looking why we are excavating. Okay, then you do foundation, then you have pedestal, columns, and you have clean beams. You have layers and layers of education put in order to create an object which doesn't have any relation to you. It doesn't have any relation, and then you want to stay in that space, a space which doesn't belong to you. Okay, so this has been happening in different levels. Okay, so what is this whole building which we are building which doesn't have any relation? how does this whole building is standing? What are the forces which basically, probably help this whole thing to stand. So coming back and then look at this, this monolith, which is above the ground, you know, uh, what are the factors, what are these factors which basically, has stability to this building. So, you started looking at this, and then finally you start looking at this build form in analogy with nature. You look at a tree for that matter. It is it is so simple, and it is so, you know it's so simple. The way is, it doesn't show education to a great extent when it is growing. It's not bothered. Okay, so when you sow a seed, can you imagine when you sow a seed, on this soil? Okay, you don't even bother to embed it. So it has two forces which basically, one going above the ground, one going below the ground. See, the two forces which it is looking at is, one is the sun, one is the light, and the other one is the water. And it seamlessly, grows, in tension, which finally becomes a big tree. Okay. Why do we have this complicated way of building it? Why are we looking at so complicated? So why can't we slightly extrude the building from the ground? Why? If you go back to the history, people started, stability through density. Okay. Today we are in the world of, looking at low density material, and then, stabilizing through stiffness. So in this whole, inquiry, so I thought there is something which has uh, some reference of seamlessness which belong to this earth. Okay, and this is based on something which you don't even see, gravity, and something which is beyond to our scale is the sun, the light. So on this basis, I just thought I want to, explain, some of my, understanding about this whole nature as it is here. So I think this one which basically provoked, me to thinking. Gravity is the hidden geometry of space. It's written by a physicist. He's not even an architect. He's a physicist. He you see the gravity of this statement is amazing. It's like it provokes you, and then it takes you into deep understanding of, how any structure above the ground is held by gravity.
Right.
And to me, this is what I started understanding is density is dictated by gravity, whereas lightness is dictated by stiffness to achieve stability. Today we are in the world of anti-gravity. We have materials which are less dense, lighter, and it is very fine. It is invisible. Most of the architects want invisible buildings. We don't want any material at all. Okay. And if you go to the past, you have materials which are denser, heavier, dictated by surface. So heaviness towards the earth is something which I perceive, like which I see. Heaviness towards the earth, and lightness or perforation towards the sky. And forces not visible needs to be understood from their effects as pattern in nature. How do you look at these forces? These are not visible. No, the wind is not visible. The pressure difference is not visible. You know, the you know the so these are looked at as patterns. Either erosion or you see suction. You see the surface being reduced. You can understand all these things by looking at patterns in nature. And then light has the ability to diminish density. The beauty about the quality of light is, even the stone can look like a paper when there is light on it. It's a fantastic, experience. What we, a stone which is on the ground. Okay, you feel that nobody wants to lift it, but
Right.
nobody is worried when the stone is above your head. When the stone is in temple, you see the stone, stone slabs, but nobody is bothered, because the light has the ability to diminish, the density. And density can be visualized as surface. How do you experience these things in your own way? I visualize it as a surface, opaque, an extrusion or an outcrop from the earth. Whereas lightness is perforated, transparent, fragmented, linear, invisible. Like tension can't be visible. Tension is invisible. So materials where density doesn't dictate gravity, especially during dry construction, confinement, or induced density through tension towards gravity. For stability, against the, for stability, so it is all pulled down through tension. That is, I think this word of confinement or inducing density is today's order. When we are looking at light materials, somehow we have to be anchored into the gravity, our mother earth, our counterweight, whatever it is. So I just skip this. I skip this, and then I just go to this very, very overall picture. Very overall picture. This is very interesting to me. So I think what I start, looking at, in a way, when I am to my scale, okay, I can see objects, but when I go beyond my scale, I see two lines which is very provoking to me, very, very scary to me, is the horizontal line between the earth and the sky. That is where we are, right? And then there is a very scary line which is called as the vertical line, which is between the water and the land. Just look at people without, they're not bothered what is below the water. Imagine for a moment, on the edge of the land, okay, if you just imagine that there is no water, you're on the top of the mountain. Immediately you're on the top of the mountain. Similarly, on the horizontal surface, you are at a great level of influence of the external forces onto the ground. Either the wind want to take over the ground, or the ground has to intrude. It has to take away the sky, the space. Similarly between the water and the land. So when I look at in that context, if I can explain anything as a structure, as a growth on the ground, you see that how an element which is subjected to bending as a short span can finally lead to large span with pure forces. Any large span is basically held by only pure forces, either compression or tension. This is what which is, this sketch is giving you an analogy with a tree. By looking at a tree and by looking at how you see forces as compression and tension as part of the element, and then how it suddenly fragments into individual forces as we increase the span. So large span structures are either pure, it is not bending, it is either pure compression or pure tension. So go back to the next, my very interesting interest of in nature is a coconut tree to me. This existence is between the land and water. The first wind will come and hit the coconut tree. So what is this coconut tree made up of? If you observe the coconut tree, the way it sheds the leaf, the surface, the texture of the surface as what you can see. And if you look at the cross section of the coconut tree, you look at the coconut, say you have porous in the center and very hard strata on the periphery. You look at this, and to me, this is a fantastic example of concentric springs. This is nothing but I perceive this, I see this as a spring. If you look at this image, I look at this as concentric springs, okay, which are seamless, and every moment it is strutted by a compression member so that it doesn't come back. So it is pre-stressed, okay, and confined. And you look at the cross section of it, it looks like a star. It's fantastic. All these struts are nothing but triangular formations which struts the spring and then keeps that so rigid and still so flexible. So that's why I tell most of the engineers is, luckily this tree is not designed by an engineer. Okay, if this were to be designed by an engineer, I think there was no existence of any coconut tree. Okay, because this tree has the ability to flex and come back. It doesn't hold this force. It allows the force to relieve itself and then come back, because of the effect of the spring. And and these are, this is also very interesting to me, is like, when you look at this sketch on the left hand side, how do you build buildings on a hill? How one builds a building on a hill? Because most of the people don't know how to build on a hill, because what they do is they cut the hill to a flat terrain and then do what they do for the flat terrain. So there can't be a concept of a retaining wall for a hill. You can't retain a hill. It's impossible, right? You can't retain. So what I understand is, the horizontality is basically held by a strut which is normal to the slope, and then the tension, the horizontal tension is held by the earth itself. The earth or an anchor, either it has to be connected to the rock. But if this same thing is reversed on the right hand side, okay, where there are a lot of architects, Hazog Demrong has done a very fantastic stadium, so wherein you have a saucer which basically becomes the stadium, okay, and the horizontal surface is the ground. So how do you look at the same thing on a flat terrain with a sloped surface? So this is something which I am interested in the sense that how do I relate without changing the formation of the earth, and how do I belong to it without even scratching even 1 mm of the earth? Okay, so this is, I think this is what we need to learn, okay, by understanding through forces which you don't even see. Okay, so that's the beauty about that.
Manjunath, can I come in?
Please.
Yeah. So I think it's interesting when you come to say discuss this particular thought, where you mentioned about the line which defines the densities which are below the earth, and there are densities which are above ground, above the ground line. And I think that's exactly where the growing of the building is, where you are imagining. But in this precise drawing, I think what you have is these forces which keep balancing or speaking to each other through these densities, which actually make the form of the building, or the expression that as the tree expresses itself, the building itself sort of then becomes the expression of these forces. But I was also quite interested in the way that you mentioned of the seamlessness that goes or that travels across this line up and down as well, because it transfers forces to the ground through gravity. But at the same time, materially, it is growing growing from earth. But
Right.
the last thing that you just mentioned right now, I was a little like I was just trying to think that what, as a construction, as an activity, or as these things, it's very you have to excavate ground, you have to sort of move earth. But
Right.
when you mention that, okay, if you want to not disturb anything of the earth, then how does one approach it? Like, what is that approach that you are like kind of mentioning?
No, in the sense, see, what I'm saying is, you see, the intention should be, even to scratch the earth, you have to be double sure. You have to be double sure what is that you are creating. Okay. Your creation should be in line with the seamlessness of what you don't see. Okay, which is very important today. Like today, what is happening here is because of the machines. Before the building is designed, the ground is already cut by the earth movers. Somebody decides that I need to have 3 floors of basement. Okay, somebody goes there without thinking and then excavate volumes of earth. Okay, and imagine finally if they don't build it, it's a wound to mother earth. Right, the amount of the age which took to confine this earth has become porous, right? So how do you confine it now? It's a damage not to you, not to your region. It is part of the whole world, no?
Yeah. Actually, but at the same time, the more interesting thought where that idea of seamlessness becomes quite quite interesting is it pass, like there are some things that you can see and experience and perceive, and there are some things which you don't, like the forces and the whole the wind, the light. So all of these things that make anything stand, like where is the question of stability? Like I think you mentioned this idea of the stability which comes in through stiffness, through maybe through other kind of elements which become in relationship to each other. So what is this sense of the visible and the invisible that really kind of makes a building? Because what we see is the kind of resultant, or you can say if you know the idea of this space and the anti-space, sort of anti-matter and antimatter, no, by which we define our.
So I think this word seamlessness, is very important. Okay. But why I'm saying is, when you look at the visual part of what you can see, okay, should have the ability to take you into the invisible part. Okay, that is what is seamlessness. If an ability of the visual element, what I see as a build form or an installation or an art form, because finally should draw me, to be able to perceive, the invisible part. That word is called as seamlessness. Okay, it's the connect between the visible and the invisible. It's the common thread which ties between what is invisible and the visible. Okay, is the thread, Okay, but what is this? It is not still, putting parts together. It is not about putting parts together at all.
Yeah.
In the process of putting parts together, which is visible, okay, do you already have gone through to see what is invisible? Okay. So that is what is called as the growing the building. Growing a building is going through the invisible part first, okay, to be able to create it without effort, without strain, as a part of seamlessness. Okay, so this is what I am saying, in the sense that we look at the build form and go back to the invisible. I start from the invisible to create something visible.
Yeah. But there's also another sense of invisibility. like after the form is in place,
Yeah.
there are forces, there are chemical, you can say, reactions which are happening. There are all kinds of things happening even after the assembly which is done, or after the kind of configuration the material kind of takes up. So
Yeah. Yeah.
it never stops. It's in that sense, in sense of time, it's also kind of seamless. And so how does one sort of, because, and it's interesting because as an engineer, I mean, starting
Yeah.
your journey from engineering, I mean, you deal with all the invisible forces because before you even think of putting together material, or thinking of matter together, or like how would like, and where did this kind of whole sense of invisibility sort of come from? Like, and how do you see pre and post of this whole process? The
So
sense of.
I think it doesn't come. It doesn't come. You can't read it. So there's a lot of things which happens to you in the sense that so when you are looking at critical projects, a project uh, which is dictated by a lot of limitations, okay, then you start at some point of time you start looking at your scale, okay, and at some time you go out of your scale, okay, to perceive beyond the scale. When you perceive beyond the scale, the beauty is you become invisible. The creator becomes invisible.
Mm,
Okay. When I become invisible, that is when, you know, I'm wandering, with experience, because I dream because I don't exist. You understood? I don't
yeah,
exist.
yeah.
But I can go into the material, I can feel it, I can enjoy the space, I can enjoy the force, I can feel the failure, I can feel the failure. Okay. Sometimes you have to, move in a day. This is
Mm,
what happens to us is, moving from, one scale to the other scale. Just to look at this, because this whole thing is about understanding the building to a great extent, okay, and experiencing the building through forces, okay.
yeah.
So I think, it's like there are very small exercises, like, when you are working with a bamboo, you
Mm,
know exactly what happens because you hold a force actually. Okay, because people are not experienced bamboo because they hold bamboo, which is a bundle of forces. So people confuse that bamboo as a pipe, steel pipe, you know.
mm,
Okay, you have to fragment bamboo into a small pieces to find the real, tension,
mm.
Okay. So you understood what I'm saying is,
Yeah, yeah.
we don't even look at bamboo as bamboo. Unfortunately, that we most, all the people all around the world, consider bamboo, treat bamboo as a pipe, which is unfortunate. You know, you understood,
Yeah, yeah, yeah.
So
But it's
it's
also bamboo. I mean, looking at bamboo as fibers, kind of, that's one level that you kind of pass through to become invisible. And then
right.
post that, I think there is also, like, there are many scopes to sort of look at it. So instead of looking at the material as in its absolute form, you start
Yeah.
understanding what the material has to offer, or what is it composed of, what is the matter, or what kind of what is the, you can say, range, or the dynamic range between material and matter. When does it kind of become?
You see, I think most of the material, okay, uh, from which you can create are all invisible, you know
Mm-hmm.
okay. So materials which are visible are only fit for duplication,
Okay.
okay. So like, say for example, cotton, can you ever imagine that cotton one day, you know revolutionize clothing?
Mm,
How did people imagine,
yeah.
like for example, soil? How did anybody, from soil can you make monoliths on this earth? Monolith buildings, huge. 20-story building, 30-story building. Imagine, it's impossible. So what we also should understand is this came through history, Okay, people started carving out from monoliths, okay, to create an image which they started building it from the fragmentation to a build form. See this beauty, how history has helped, history, like people started carving out from the monolith to get back to use the same material to build.
Right.
Yeah, it's fantastic. No, it's fantastic. Today we do everything with machine now.
Right.
What is called as whatever.
It reminds me of this Kailash temple. No.
Yeah.
I mean, and I think right now we are.
It's a fantastic. Yeah. Fantastic. Kailash temple is one, and second thing is this in Jaipur. You have this, Hawa Mahal.
Right.
Hawa Mahal. I was just talking to an architect, Flying Elephant Rajesh. We were just, talking about how one shape, one size of different scales, has put together to create an environment which is totally different, magical. Each element of different shapes are put together. Is the inspiration came out from the carving, because everything is very thin, but scales are different. One is small scale, one is big scale, one is higher scale, and people move within that, to create, to experience the movement of wind, which is fantastic. How do people get this idea, and why people are not getting this idea? It's a question, no, basically.
Yeah. So do you want to also build up from other things that you have for us today to show, or because I think there might be other interesting things which open up from.
Yeah, I see. Basically, I just like I'll just show you some very very simple, which is this is, I think I want to show through this experience, okay, through this understanding of this environment where we belong, and to understand this sensitivity. How do you create buildings? How do you create buildings? If you are given the chance to take, to create a building, how do you build buildings? So this is a very interesting project which we did in Kunnur, like a building on a hill. How do people walk on a hill? So when you walk on a hill, you put your first leg, in compression, whereas the second leg will be in tension. Basically, it balances you. Okay, what does that whole act will do to the body? The body will become stiff. There's a twist. There's a twist because of this movement. So your, shoulder becomes very twist. This becomes very strong. So keeping that, this principle, I created this building. Just in the sense, created in the sense, it's a concept. It's a concept of why we can't do this building. So I'll show you some images of this. So look at this building. This is done with minimum material, okay, steel, which is fragmented, okay, fragmented to an extent that you can hold this material in your hand, okay, and you can combine it to your requirement, okay, of understanding of the force, and then you don't weld it, you bolt it. Everything is prefab, is built somewhere and erected somewhere, So this looks like as temporary as like an insect, I think this is going to stay for 1 hour, okay. After that, it is not there, So that quality of temporariness is very important, in a build form, where you should allow the sunlight to come to the ground, even to touch the ants below. That is the sensitivity at which we have to start looking at, any build form on this earth. So this is, this is the, this is structure. This is about 10 years old, going strong, still looks, so temporary. Okay. But it is married to that, environment, it doesn't want to go now. It's there to stay.
So also, I think what this opens up, I think there might be some other things, other projects which might open up, but maybe I would provoke you with two questions.
Please.
By which maybe we could, also look at the other following projects. So,
Right.
With this idea of the invisibility, or with the sense of seeing things as a seamless condition, seamless
Right.
material and matter condition, what kind of new tectonics emerge from this sense, or what kind of new sense of seamlessness influence the way we detail things out, or the way we kind of put things together? Is there a new approach, or is there what emerges from this sense? And I think maybe some of your projects do that, or maybe what would you want to do with this kind of
I think with this thought process, I want to remove the redundancy, redundancy in the system. I don't want to build unnecessary, what you call it as, element of, fear in building. I don't want to waste material here. So the best way to avoid wasting material is to work with fragmented elements which are unstable. Okay. Very fragmented elements which are unstable, and combine to your requirement very intelligently to make it stable. Okay. So this is what I call it as not physical weaving. This is what is called as mental weaving. You weave mentally, okay, intelligently, okay, so that each element does more than one purpose. Okay. Like if you see, you must have seen in airports where, the layers of redundancy, in the sense that you have a structural column which is supporting the building. Okay. Then you have another steel column which is supporting the glazing. There's another steel column which supports the louver. There are three layers which are looked at three different levels by three different agencies to create a shabby structure. You understood, in the sense that, layers of, elements which are not thought over, because the building is one.
Right.
The building has to be one. But people can't be like education, no? Like there can't be, when you want to create, there can't be a layer of education. Everybody melts to create. That's the beauty. You started as engineer, but you don't end up as an engineer. No? Everybody has to end up as a creator. That is the beauty of evolving. No? Right?
Right.
If you still remain as an engineer forever, what is the point? Right? So this is what I say is, you start with a brand, but you have to end up as a creator. A creator always has to be a collaborator.
So to kind of take this idea of collaboration ahead, what like right now you speak of the tree, the way in which the nature sort of grows. What sense of say collaborations you draw from, or you see the structure really responding to, like who do you collaborate with? Is it like human sense of seeing things? That's one way to see, but there are also these other forces, or maybe other organisms, or maybe other sense of seeing things. Like you draw the relationship between a tree and a building, which both grow. So I think that will be one interesting way to sort of relate it. I mean, I know you have spoken about it a little before, but right now I think with just furthering the question of the tectonics and detail, and to kind of draw in this idea of the redundancy in the system, like just to kind of provoke, our current systems or current building assemblies not say optimizing enough, and if they are optimizing, or if they are kind of trying to move towards this seamlessness, uh, it doesn't kind of like think through the way say the nature sort of does it, or maybe because the way in which a tree grows. Now I'm really getting into the way in which really matter forms itself. And I would also want to draw in this idea of the gravity, because under gravity, like the angle of repose that the soil takes, like it kind of it has a certain behavior under gravity. So are there ways, or are there processes, or can we think of using these invisible forces to really develop or think of new tectonics, or new details, or new formations of material, rather than only kind of being limited to existing available elements? And I think what you also spoke just now is this fragmented elements, kind of which are unstable, and putting them together. So I think all of this tied together, I just want to think of of possible processes that emerge from.
No, I think the Earth is posing a challenge to humans to create in a way that it is seamless, and it is seamless. That is what the Earth has no restraint. It doesn't have any restraint. It takes all this shit. Finally. But what is very important to me is like the 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 way you see unstable above the ground is also should be completed through what you don't see. Okay, because finally when you see what you see and don't see as an element of geometry, okay, then it is seamless. Okay, see what you understood. One is, say today when I look at this structure which is visible as unstable, okay, as a view, okay, but I complete it through what I don't see, what people don't see, okay, which is buried as forces below the ground, which is seamless, which is stable. Okay, so we need to, it's very important that before you look at the visible part and then go back to stabilize it, okay, I would like people to go back to the invisible part and then create, respectfully what they want to build. I think your dream has to be slightly conditioned, okay, or to be in the line of what you create, which is more seamless. Okay, so say people come to us with they want very less number of supports, okay, but they want everything to be free, column free, and they want everything to be projected. Fine, it's fine, your dream is fine, okay, but you have not looked at what are the forces which basically make you a structure to keep, and what has to be buried below the ground. Nobody understands, nobody is bothered also. No, what is not seen is not what they want. What they are not bothered. They're not bothered. What you bury it, I'm not bothered. But here in this in this talk is I want to show what is buried, okay, is as beautiful as what you are creating, okay. And then if you create, you understood.
No, that reminds me of your idea of weaving. And I think that what this weaving did was kind of shifted the whole the detail on in which all these steel members came together, or the way in which they sort of transfer the forces, or how it articulates a column, or how it articulates even a junction. So I think that I felt that kind of works, and I took that step in addressing this question of this tectonic, or the detail by which, and the process, like for example the invisible aspects of the forces really pushed, I think, that the weave to happen with the same elements that were kind of bolted or hinged or fixed to each other, and now they are continuous. They work as a continuous sort of line of force. So I think that shift, for the way I see, was kind of interesting, and I want to really kind of take that a little further. And on the other hand, the project, I think, which I remember, maybe if you have in the slides, we could also see the stone project, that like the house. I think it's a house which with stone, with
I'll show it to you.
yeah.
I'll take you into some few, on the same language, okay.
Yeah.
So this is very interesting to me, like how do you try and then use, a simple bend material. You take a flat, the flat, to keep that aligned for a long distance is very difficult. The flat can twist, then how do you make it more rigid? Is to bend it by 90 degrees. So it becomes an angle. So the beauty about an angle is it can be a channel, or it can be a back-to-back angle, but it can also be a box with 4 angles, okay? Or it can be an eye, with 4 angles, 2 angles on top with a plate, So when you are able to fragment with such a simple material, okay, how do you want to choose, having understood the behavior of the structure to your own need? What is wrong in it? You don't need education for that, no. So education is only to absorb the essence, okay, and use the essence to create, okay. And see, this whole building is an architect's office, where we created is 2 floors of suspension and 2 floors of steel structure on a core which is a monolith, which is sitting on the ground.
Right.
Okay, the monolith is not 1 column; it is 2 columns, so that car can be parked below. Okay, so the idea is very simple. It's not very complicated, and it's not complex at all. Okay, how do you fragment the single support into 2 elements where the car can be parked? How can you suspend it? Most of the the nests, all the nests are all basically suspended structure, right? All are done by fibers or grass. It's all grass. Okay, so it has the ability to take tension. So what we created was this simple light structure. When you look at this structure, you see, what is this? It's just fragmented, like stiffness, and then below, you can park the car. There is no obstruction at all. When you look at this structure, you can feel the force, you can feel tension. There is a lot of transfer of energy, into there is zero redundancy in this building. Okay, why can't we create these buildings with zero redundancy? In the sense that it gives you a feel of a human being. Actually, you have a spinal cord, you have a spine, you have the ribs, and then it's all suspended. 2 angles become a plus column, which is stiffer in both directions, which gets concealed when you are doing the wall system. It just is like it just gives me an indication that you put the wall and fuse steel in between, or the steel is well within. That's what I'm talking about growing. You choose a section which is seamlessly, occupies the space of invisibility. It doesn't show. There's nothing to show.
Yeah.
What is there to show? Right? Okay,
Yeah.
this is one of my very favorite projects. You see this lightness. The first photo, you can see that it's a cage which is suspended, which is holding 200 kgs per square meters at two levels. Two live loads. So this is also steel weaving in a different language. Steel language with plates. Where finally it is invisible. But the experience is fantastic. The experience is you can feel in a space wherein the structure just marries into the opacity of the surfaces. Just
Right.
it doesn't, you don't even see where is the volume. The volume is just, it is so shy that it just goes behind the surfaces. Okay.
Yeah.
So
no,
this is
I think
another
that relation that you made with the monolith and this sort of very fine thin layer of steel which kind of comes around, and I think but in terms of, I think what the more important thing, I think what you opened up is the experience of it, because you don't see it, you don't see the kind of massiveness or the kind of expected perception of or the visible sense of the structure, but at the same time I think it is kind of holding mass, at the same time kind of getting invisible by itself. So I think that's an interesting relationship where you starting from thinking of structures as invisible, or that seamless shift from invisibility to kind of making a structure, at the same time it becoming invisible in relationship to an existing sort of material like of the core or the concrete mass that is there. So yeah, I think that kind of builds a very you can say interesting dialogue between two materials, like one which is also casted and the other which is also kind of assembled together. So, and also thinking of these two processes, like one coming from a composite sense of being like you actually making the bone of the body, the way the bone grows, and the other is where these sort of other finer cages emerge. But at the same time, I think that, and it completely shifts from here to the monolith that you actually have. But yeah, I would ask you to kind of go through this before we enter there.
I think what is very interesting to me is some of these words, which has some meaning, like strapping, strapping, strap. You put a strap, what is a strap? Strap is holding tension only, okay. You hold tension, okay, and being part of confining a loose particle, you're inducing, compression through tension, okay. Every parcel is being, taped, strapped, so that that becomes seamlessly monolithic to induce density. I think that is what is very important to create a building today. How do you strap? Okay, not by the literal sense of strapping. How does it finally get strapped? Okay, to a level where I start increasing density. Automatically, this tension will latch on to that and then become monolithic. That's the beauty. Like say for example, concrete and steel. When it sets, that is internal. How do I create this something which as a process, okay, it increases its strength. That is the beauty of weaving. Weaving is, it's a measurable strength increment as a process of working with unstable elements to make it, stable, combining unstable elements to make it stable. Look at a bamboo basket, no? Simple, very simple. It's not done by an engineer or an architect, no? It's somebody from the past, from the, passerby, it's a craft. So what we also should understand is, how do you look at working with a material and then understanding the material to perform in its own way? So how engineering and craft can come together. Okay, how can you craft a building? Okay, these are two.
This is also interesting because the way you narrate it or the way you speak it, you actually become that material while thinking of it, and you are actually feeling those forces, or you're kind of thinking through. Actually, you have become steel here, and you're thinking, like you and that matter or the material is one. So I think that's quite interesting. And also that brings me to this another aspect that you mentioned, that you are invisible in the process, or as a creator, as a maker. And I think I would bring in this sense of intuition over here, which is an invisible force within us that kind of speaks to us about the experience of the force and the way we shape form and material through that. So at the same, I think we all sort of have that sense, and as you said, that education may or may not prepare you for it, but there is this intuitive sense of these forces which actually would. So I think I find that quite interesting, where like right now when you spoke, you became the material through this intuitive logic, or the intuitive sense that you have built through your experience. Yeah,
I think it's, education is important to an extent where, you start dissifying it. You have to distill it. Distill it to a level that it doesn't become visible. Never take education visible. Okay, you have to distill it invisible, which should be with what I call it as experience. I think we also, we don't observe to an extent. There are so many things what we see. Either we observe visually, or we go beyond what we see. Into other things. So what I think what is very important here to me is the invisible for somebody is some sort of an experience which I can create as an visible entity. Okay. I think that will come the more you get attached to what you do. Okay.
Yeah.
And you also mostly see beyond what you see, and also you start relating with what is existing before us, which still remains after us also, which is nature. Nature. I think we don't observe nature. Looking at a tree, looking at a tree, it gives you everything about engineering. You look at cross section of the tree from the bottom to the top. Okay. The profile is changing constantly. Okay. The surface is indicating which is compression, which is tension, but there's no color, but you have to find a color in your mind, okay, to differentiate this. But if you don't want to color it, experience the force. Have the ability to experience tension and compression. Okay, what else you want?
It also, of course. I mean, but this also makes me think of like your approach from making a composite sort of a structure which is, say, close to a tree, so as to making a monolith, which is the house that you're making with stones. So what did shift there? Like, what was your approach there, and where, like, what are this kind of seamless conditions that it kind of worked with?
So there also what we did was,
if you can show some images also.
I'll show you. I'll probably go to, I'll just take up WCFA. Okay.
Okay.
Are you seeing the screen? Yeah, you see the screen.
Yeah.
Yeah, this is WCFA where we like. So basically, how do after this is the first project where I did this, steel weaving, because this is somewhere I felt that I want to relate to every element I use. I want to put I want to put my hand between the two columns, stand by, sit, just have a discussion, and then you sit on the bench, put your hand against the steel pipe, okay. If I put an ISMB, it's too crude, it doesn't, you can't hold a hand against an ISMB, it hurts you, right? Okay. So ISMB is, ISMB is factory made. It doesn't have, a quality of, to deal with humans, So we started looking at fragmenting elements, which you can relate, and this is how, two members will, very highly disciplined, go up to a certain point. Then after that, they become indisciplined. They are independent and they do different activities. One is supporting inside, one is going there. Boss. I think too much of belonging together. Okay, let me do my own. So these columns are doing very differently. Each one is going up to certain point. After that, it changes. So if you look at some of the images, like how these columns enter and terminate and how it allows the other person to come and then stand on it or perform, a music or a poetry, Okay. So it gives you, a sense of playing, it's not about regimentalizing, it's about play, just relieving yourself, to the form of the roof, Okay. So you look at this, each member is going side by side, not interfering, no welding, just managing to be there up to certain, they enjoy their association at a given point of time, do that activity, and then go beyond, they're not bothered, So small elements of, of their belonging. Yeah, this is the stone, So this, I think this is a very, this is a very nice material, a material which is a jewel, It's a jewel on this earth. That is why it is not showing that it is jewel, no? Okay. It's not showing, that please come and collect it. No. Yeah, it's not. It's all buried inside very nicely. You have to remove it and then to take this. And so these are in Bangalore. We see these as manhole covers, drain covers, chubdies, toilets, benches. You see as a childhood, no. On the roadside you have seen, this is what I have seen, okay, and this is what is there existing,
Right.
you don't need to create anything, no, something is existing, they use compound walls with this, they put it vertical and compound walls, everything is there, okay,
Right.
So how do I use this beautiful surface, okay, with the availability, and then how do I combine it in such a way that, okay, through combination in a particular organization, okay, by density, I confine it. Okay. Okay. Through density, I confine it. One will not confine it. As a group of members in a particular direction, through density, it will lock itself. Right. Okay. It will lock itself. This whole process is no nut and bolts. No nut and bolts. Nothing. Okay. Everything is dry joint. The undulation between the surfaces are grouted for sealing. Okay. Otherwise, it's just placed one above the other, locked by density. Locked by density. Okay, locked by density.
So
okay,
what do you mean by this locked by density? Like, does it interlock two stone slabs into each other?
yeah. So what I'm saying is, all these columns, are in plus fashion. Okay, so there are two walls. Okay, which the other one wall will go inside that. Okay, so it is well arranged. I didn't take the whole thing. See, you see this actually. You can see the inside of the wall. You see these fins. Finally converge as a plus in the center. So these are nothing but 9 squares, which makes the house. Okay, the center one is a courtyard.
Right.
Okay, and it is a standard format. And every joint you must be, you look at this joint. You see this? Everything has a CT. It gets locked.
Right.
It's a very simple, but what is very important? What is very important?
Sorry, go ahead. No.
So what is very important is the visual element is very similar to RCC. You can't change all those things. But if you observe it very closely, it takes you to the journey of making it. Okay, being stable, if you go further, it takes you into the journey of the forces below the ground. Okay, how it is going to anchored into Mother Earth. That is the quality of natural material. Basically, it tells you a story, okay, of making. You don't need a creator here.
Right.
You don't need, actually, because the building talks everything without making sound.
This is the southerly stone, right?
Yeah, this is southerly stone.
Yeah, it's a granite. And I think also what you were speaking of the redundancies before, I think this is a quite interesting example to sort of look at. How thick is that wall? How thick is that slab? The vertical one. That
4 inches to 5 inches.
Okay, wow, 5 inches and
100 mm
right,
thick.
Right. And what about, like, and what about the other elements that fit into this? Like, what are those sort of tectonics, like where the window fits in?
No, I think I'm basically, since I am just an engineer here. Okay. There's an architect. There is difficulty. Okay, but everything can be solved in the sense that this material itself will give you direction how you have to live in this place. Okay, but I stayed in this place one evening. It's amazing.
Right.
It's beautiful. It's it shows the lightness. The light quality is amazing. And you can't even imagine that this is stone.
It should be quite interesting, because it's from the same material that's found around. And and kind of, when you say it kind of fixes or locks itself inside the earth, where it actually is excavated from. And I'm sure, I think, I don't know how deep is the bedrock. Like, is it so?
No, this is the whole thing is a stone foundation only. There's no RCC here.
Oh, okay. So it's within the stone that it's kind of.
It's a stone. So you have a very well confined stone plinth,
right,
which finally is a monolith. It's a perforated monolith,
right,
of stone.
One can say this as the contemporary version of all the temples that we see around. I think
so this is what I come back and say is, if I were to give, if I were to be given a monolith of stone, the extent of carving, into the space will create even more better space and better thinness. Okay. See, people started carving only to the need.
Right.
Okay. People started only to carve to the need. Okay. Today we are in the world of greed. Okay. That's why the material thickness have reduced. Okay.
Yeah.
Right. Okay.
Yeah.
So you see the possibility even in the history. Okay. If we had a better engineering or better engineering thought process, we could have supported greed also.
Right.
Huh?
Yeah.
By carving out more. Huh?
True. Yes. Yes.
Okay.
I think we should open up the conversation, because I think everybody is shying away from participating. I think let's open it up for other questions and comments.
Yeah. Please.
Anyone who has a question, please raise your hand, and you could come in and ask or you can say contribute to the conversation. So,
I can remove this slide.
Yeah. Please. Yes.
Okay. How do I? 1 minute. 1 minute. Give me.
Yeah.
Abhi, can you remove it?
It's gone. It's gone. The
It's gone,
presentation
is it?
not. Yeah.
Okay.
Yeah. So, if you have written questions in the question box, no one yet has. My colleague Milind is here.
Yeah.
Milind, if you want to. Hi, Milind.
Hi, Mil. Yeah.
Long back we met.
Yeah.
No, I just means it's always interesting to hear your talk, and I'm very fascinated the way you think through the material. I just always have this thought: how do you arrive at this point when one of the sentence that you said that if you take a ISMB, you cannot put a hand across it because it hurts.
Yeah.
So how do you come to this point? Like, how do you make aware of this point through various things to pursue a architecture student or an architect? Like, what is the conversation that you have with the architect to come to this point where you can tell that rather than using this ISMB, we should use maybe a box column or a box section.
Yeah, I think it's I think it's all about to 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 fragment it to a level that you don't see a shape. Okay, so in the sense that in ISMB is what is ISMB? Okay, first let's understand what is ISMB. An ISMB is two surfaces with a web. Okay, what are these two surfaces doing? Either it takes compression or tension. Okay, that's why it's called as a flange. Okay, and the web is a separator. Okay, the deeper the web, the forces are less, or the ability to take force is very high. Okay, so what does these two surfaces? So can I create two surfaces without taking ISMB? Okay, so I have to make a lattice. Okay, so what is happening is understanding the material, okay, and the shape to the requirement of why it is made, okay, and then using that understanding of handling the force and then replacing other materials to respect that force. That's it, nothing else. Okay, you don't need to study engineering for that. Okay, if you want to, if you want to understand for that, you do, you go to the workshop, you try out, you sit on the beam which you have created and see what is the load. Nobody's stopping them. No? Nobody is stopping them. I think some level you need to be to understand a material to your scale. Okay, somewhere you have to go beyond your scale to understand the same material in a different perspective, okay, as a force, okay. So these are like whether this I section is made for a bigger structure, is extruded for a smaller structure without understanding. It's like you take two elephants, no? Very simple. Okay. You take big elephant and a baby elephant. Both of them are looking same actually. Okay. The smaller elephant is not made for the big work actually, because it is made small, that's all. Okay. But it comes to use only when it becomes big, right? Correct, no?
Yeah,
It
it
becomes big,
scale.
That is what the scale is all about,
Yeah.
Like as a child, most of the parts are not useful. Okay. Correct. But it is made like human because it is going to grow as a big. Okay. So the scale of shape should not be diluted, Okay. So that's why you need to look at your scale first and then go beyond your scale to look at it. Okay. Like bamboo, I was saying, no, bamboo is made for Lilliput, not for Gulliver, Bamboo is made for Gulliver, not for humans. Understand? One fiber of bamboo is for humans, actually. What did we understand bamboo? Okay, we understood bamboo since humans, we understand bamboo as a pipe, MS pipe. And what we do for MS pipe, we do for bamboo. It's a disaster, no? You bolt it, you put a washer, you tighten it. What are we doing? No? You understood what I'm saying?
Yeah.
So sometimes what is made should be understood beyond your scale. Okay, then it makes sense.
Yeah.
It is considered as grass, right? It is considered as grass.
Yeah.
But we consider that as a pipe. Huh?
So there's one more student from C, Rishabh. Rishabh, you want to ask your question?
Yeah. Hi, Manju.
Hi.
So, when you were talking about the air between the structures, I mean the one which you did on the hilltops, the house with the
Yeah.
The structure was so light that I could almost feel the air. I mean, as here, if I were there, then how would I experience that space? Yeah. But that's it. And then you also mentioned one thing that each, I mean, the sunlight should also reach to the ants on the ground.
Yeah.
Yeah. So actually, that got me thinking into the. I mean, so this was about space, but when I think about the matter and such, the materials used, the lighter the structure, the heavier was the resources that were used in it.
Lovely. Yeah. Very good. It's a fantastic, it's like, like you saw Alvaro Caesar's pavilion,
Hmm.
It's just a sag, it's a sag for so long, to contain that sag, okay, which is actually the respect to gravity, okay. There are two buildings, you have to create two buildings, okay, to have that sag for so long, you have to create two monoliths, which are two buildings. So how density is playing for lightness, you understood? Okay, so this is what is very important in the sense that how do you very nicely want to show lightness without showing heaviness, okay, is also very important. Okay, is very important that lightness could be visible, but there is something which is buried as heaviness. You understood?
Yeah. Also, also also while you decide the material and the lightness key, uh, it should be lighter and also feel lighter. When you're arriving to the materials of it, to decide as to, okay, I'll make this with stone, or I'll make this with steel, or I'll make this with wood. In that one, I'm asking, what goes on to the embodied energy of that material from the moment it has been extracted from the forest to processed and now being used as steel. So, do such questions also come into discussions before or in your mind to decide, okay, I might be able to make this with wood also, but because of this, I mean, so that I feel the gravity and the structure of it, you use steel. So I just want to understand that process when you arrive to a material.
Yeah,
And
yeah.
say,
So that's what. So all this thinking is invisible. Okay, it is not visible.
yeah.
So even before you build, even if you put, before the first stone as a foundation, just tackle the invisible aspect of it. Okay, if you are marrying densities, either it is stone and wood or stone and steel, whatever it is, you also should look at how are you taking this material, from where it is coming. Okay, how much of materials are there already, without excavation? Is there something which I can do? So when you look at, everything without getting the visual aspect of the material, but the you know the technical aspect of the material through density, okay, then you are free to choose. Okay, you're free to choose, and then every product becomes surprise for you. If you start choosing a material, okay, initially, okay, and then looking at density later, okay, then then you are married to it, no, then you don't dilute it. So I think these are things which we have to be very careful, in the sense that, if you want to marry density, concentration or heaviness, okay, could be a surface, because then you have to have compression there. If you want to have lightness, then there has to be perforation. Then you choose a material which has more concentration but less area. Okay, then you can choose steel. Okay, then how do you allocate it? Because the whole, like I was telling, no, heaviness towards the earth, perforation towards the sky, because the light has to percolate and then touch the ground. So these are, thought process which we can more or less get you into the, law of nature, and then, somehow you can see, start experiencing the product. Okay, it
Yeah.
doesn't look like a tree. Your building doesn't look like a tree. That is one thing which we have to be very, not bound by, like, creating a tree house which is looking like a tree. That is the most disaster. Okay, the essence should be a tree house. You can't make a
Yeah.
tree in concrete and then put a house over it.
But in essence, when you speak of essence, Manjunath, in essence, no, Rishabh, I also want to bring in this in the question of energy.
Yeah.
In universe, energy is constant. So I
Yeah.
think that the way in which we approach this, or we kind of see this question of energy, should also kind of account for that whole law of physics, or the law of
Yeah.
universe is
100%.
sort of
100.
working on. And I think what you mentioned with these densities, it's all about that. It's all about kind of transferring the energies rather than
Yeah.
looking at the embodiedness of it, or maybe other, because I think those energies are being transferred in some way or the other to
Yeah.
many. And I think there is also, I would like to kind of bring in another question which is linked to it partly, which where Athatva speaks of what kind of changes are going to come in materials, and also tell us your perspective about vernacular materials.
Yeah, I think today we look at the materials, only on the visual count. or a necessity count, like somebody wants to, rated, platinum rated, let's use fly ash. Okay. And then nobody is bothered about, the stability of the fly ash or the ACC blocks, and they go as thin as 100 thick for 4 meters high, No, so are we looking at materials without knowing their, inherent, strength, inherent quality, So, what I'm saying is today we have so many materials for different purposes, you know, like you see, especially flap, blocks, it is not stable at all. You make 8 inches blocks, okay? It has density of 600 kgs per cubic meter, cement and, raise the block for 8 feet.
Yeah.
If somebody leans on it, the wall will fall. So people say there is a collapse of the wall,
Yeah.
Nobody understand the for the density, there is insufficient width, If you have to use 600 kg per, if you have to use 200 thick block, which is 600 kgs, okay, you have to make it stiffer. No, you can't make it as built like a 9 inches only. You have to have, like you have to have baffles in between, or you have to have thicker walls, So that that shift of thinking is not happened. People start relating Eurocon block and okay. So why I'm saying density is so important here is, see, visual thickness is basically representing, two blocks as shape. But when you look at density, then you start working about stability. Okay, lighter density, thickness has to be there. Heavier density, gravity will take over. If you understand this, then you are very safe. No, you don't make a mistake of using 100 block for 5 meter high.
Manjunath, we are losing. I think there's some disturbance in your audio.
Can you hear me?
Now it's better. I think, yeah. It's
okay.
So we have one more ex-student from C. Ashwin. Ashwin, would you want to come in and ask your question or share your comments or? Ashwin, are you here?
Hello. Hi, Manjunath.
Hi.
Hi.
I just wanted to ask, when you were talking about the structure of that coconut tree, I recently was shutting the shutter of my office, and I was surprised because there was no covering. So I found that coiled spring, which is actually this. I always imagined something that was working in springs. Are always imagined something that worked as a perpendicularly. But that coil spring kind of surprised me, and it kind of reminded me of the structure of the coconut itself. So I wanted to ask, when you were talking about structures in buildings, and there was a mention of movement when you were talking about that house on the hill.
Right.
How do you look at the structure of movement? Because movement, is movement then imagined as restricted, the structure kind of restricts movement, and then to a certain extent, and is movement then?
No, if you're talking about the hill in Kunnur, the house in Kunnur, so are you referring to the house in Kunnur?
Yeah, the one on the hilltop. I'm just asking as a
basically, it's basically in the sense that the whole growing a structure is not making each element stronger. Okay, not making each element stronger. Okay, so when you grow a structure, what happens is you make systems, okay, which are less flexible, less stronger. It's flexible. So when I'm talking about a house in Kunnur where one leg is in compression, one leg is in tension, okay, this is basically a series of springs which are layered one by the other. So before you even put the floor slab or the roof slab, okay, the spring is going to shake, because of the wind. Okay, that doesn't mean that the structure is going to shake, Okay, now the springs are infilled with surfaces. Okay, now the wall is going to come, then the floor is going to come. Okay, then the roof is going to come. So these elements are rigid elements, okay, which basically confines. Okay, in a coconut tree, what happens? Okay, see here you are looking at building which is rectangular cross section. In a coconut tree, it's circular. It doesn't matter. It doesn't matter, because once you start perceiving this beyond your scale, circle, square doesn't matter, right? Everything looks same, right? Okay. Now, in a coconut tree, what is happening? You have springs and then fibers which are confining the coconut tree. You have porous fibers in the center, then it goes concentrated and then it becomes heavy, right? Similarly, in a build form, considering the essence, you have two walls, you have two floors. That basically confines. What does this confining for a spring make? Is it rigidizes the whole spring action of the structure to an extent that you don't feel it. But still, if there is an excessive force which comes, the structure will just move and come back, Okay, if you design structures for movement, then the structure has to be heavy. What did Bruce Lee do when he was in, fighting with the other opponent? He learned the skill of, going back against the force so that the force became zero. And then he came back and then hit the other guy, right? He never took the force, no? You understood? I think it's about, there is so much analogy which we can put it, like coconut tree doesn't have any failures. No? Okay. You understood. I think somewhere, you have to look at the problem, the way at your scale, but just go beyond and look at your project and the coconut trees and something else, Okay, you look at a tower today, the tower is also going by 300 mm. You can't even imagine, that is going 300 mm.
It's all invisible. It's like it's all invisible. No, it's all like acting around, and so I think that. But thanks, Ashwin. I think we are challenged with time a little bit, and there. I think I've responded to a few questions.
I just wanted to ask a follow-up question.
Yeah.
Just so when you're talking about bending, there is this idea of strength that that needs to be maintained for something to stay. But then, as structural engineer, I would just ask that what then becomes, because this idea of density was very interesting because it kind of clubbed a complex amount of forces into something that you can understand at a larger scale. So how would you then
the choice of the material becomes very important. You can't make a spring in wood.
Yeah, but what would you call then movement? I mean, how would you then, if you're talking about stability,
every cantilever, every building on this earth is a cantilever from the earth. Every building. Correct, no? Huh? Correct, right? Okay. Right? So it has movement. Huh? It has movement. Something which you can feel, something which you can't feel. Any outcrop on this earth is bound to move because it is part of the fragmentation. It is like part of the density which is moving. Air is moving. Right? Right? Okay. Huh? So you take all buildings are cantilevers, no? All buildings are cantilever, probably concentrated towards gravity because of density. If if the same density goes taller, it has to move. Right?
Ashwin.
Yes, okay, thank you.
Yeah. So thanks for participating all the questions. I'm sorry, but we can only take so many right now, and we have kind of finished our time with this. But thanks, Manjuna. Thanks for joining us, and thanks for this wonderful conversation, and also being quite organic about it. So I think with the forces and the discussion, I think it kind of went very well. So thank you once again, and I hope we keep interacting much more.
Okay, thank you. Lovely speaking to you guys. Okay, bye.
All right, thank you.
Okay, cheers. Bye.
Bye.